you gonna sit? Maybe here? Yeah, maybe there. All right. So now we're about to start the highlight of our day. And probably the highlight of your day too. But hasn't this conference been so good so far? Yes. I agree. I'm like, yeah, it's been life-giving for me. So I'm really enjoying the day. I am certainly enjoying our speakers so far. It's been really wonderful and impactful. So we're going to go ahead and get started with our 3-minute thesis competition. I'm going to switch mics. All right. So hopefully you guys are now familiar with the 3-minute thesis. And if you're not, here is your rundown about the 3-minute thesis. So it's a research communication competition developed by the University of Queensland. And this is where PhD students have 3 minutes to present a compelling oration on their thesis and its significance. The 3MT challenges students to consolidate their ideas and research discoveries so they can be presented concisely to a non-specialist audience. That means everybody in the room ought to understand what the presenter is saying. Developed by the University of Queensland in 2008, enthusiasm for the 3MT and its adoptions in universities led to the development of an international competition. The rules are, our folks get one single static PowerPoint slide. It can't have any transitions, animations, or movement. And the slide is going to be presented from the beginning of their oration. So when they start talking, we start timing. No additional electronic media, sound files, video files, no additional props, costumes, musical instruments, or equipment. Presentations are limited to 3 minutes, and competitors exceeding 3 minutes are penalized. So my timer, make sure that you are noting the folks who might run over time. Thank you. Presentations are to be spoken word, no poems, raps, or songs. Presentations are to commence from the stage area. Presentations are considered to have commenced when a presenter starts their presentation through movement or speech. And we have a wonderful panel of judges, and their decision is final. So the judging criteria, we'll be judging on comprehension and content, and engagement and communication. With comprehension and content, did the presentation help the audience understand the research? Was the topic and its significance communicated in language appropriate to an intelligent, non-specialist audience? With engagement and communication, did the oration, photography. Did the oration make the audience want to know more? Did the speaker have sufficient stage presence, maintain eye contact and vocal range, and maintain a steady pace and have a confident stance? I'm going to ask that if you want or need to use the mic, to use this mic rather than the podium mic, because I think this mic is a handheld. You can take it off the stand and walk around with it as needed. Our judging panel, these lovely judges, thank you so much. I appreciate you guys more than you know. Dr. Piper's here, and she is a humanitarians librarian, and she's on vacation this week. So she came just for y'all. Yes, for y'all. Dr. Gladden is here. Dr. Gladden is also a 2021 3-minute thesis winner. Yes, honey. Love it. And I'm so excited. Okay. Our 2023 winner, soon to be Dr. Chaudhry, is here also. So you have a panel of judging experts right here, and former winners, and they're going to do a great job with this. And I'm so grateful that I don't have to judge, because I've seen some of your presentations, and it will be a difficult thing to do. All right, so we have two versions of this. Our first version is our 3-minute pitch, which is for post-bac folks and master's students. So this could be non-degree, post-bac, but anybody that's not pursuing a PhD, right? And the first place winner will win a $300 prize. I don't have any checks. I'm not handing you a check today, okay? It goes to your Bursar account, okay? And a feature in our GradJag newsletter. Second place will win a $200 prize, and our People's Choice winner, which is where everybody gets to vote, they will also win a $200 prize. Does everybody have their ballot? Yes? Okay, great. All right. Our 3-minute thesis students, our first place winner will win $500, and they will represent IU Indianapolis at the Midwestern Association of Graduate Schools annual conference, which this year is going to be in Kansas City, Missouri. In spring of 2026, it's going to be in Kansas City, and you'll also get a feature in our GradJag newsletter. Our second place winner will win $300, and then our People's Choice winner will win $200. So you can get up to whatever amount for 3 minutes of work. And I think Shumali won, what, $700 per year, because she was able to win first place and People's Choice. So yeah, it could happen for 3 minutes. We're excited. No, I understand. Special thanks to our sponsors. Lumina gave us some money last year. We're hoping they'll give us some money this year too. Our Graduate Mentoring Center is a Jaguar level sponsor, which means they are actually supplying the funds for our People's Choice Awards this year. The Grad School of Indianapolis, our United Professional and Graduate Student Organization Up and Go, and then our GPSG, our Grad Professional Student Government, are also coming in as Jaguar sponsors. So, without further ado, we're going to go ahead and get started with our 3-minute pitch competition. Super excited to support and to hear from our students. My timer ready? All right. First up, we've got Martin, and Martin's going to talk to us about digging deeper, how rocks teach us how science works.
How many of you have heard people debate passionately that climate change is not real? Or that artificial intelligence will take over our jobs? Or that genetically modified foods are actually harmful to our health? These are misconceptions that are as a result of people's ignorance, but most importantly, because they do not understand how science works. Now, imagine yourself standing on top of the Grand Canyon or the cliff. All you see are rock layers, like a history book. But as geologists, we do not just see rocks, but we see important foundational clues like fossils that help us to understand or identify important natural resources like crude oil. This does not just show us how to identify these minerals, but most importantly, they teach us how science works. The problem, most students and even pre-service teachers do not understand how science works. For this reason, I developed a curriculum around geology's own relative age dating principles. These principles are simple rules used by geologists to understand the chronological order in which geological events or geological outcrops actually occur. Through this approach, we did not use the usual lecture-based learning, but we adopted the historical storytelling as well as a hands-on discovery approach. By this, students were able to identify themselves as geological detectives, piecing rock layers together, understanding and debating their interpretation, as well as immersing themselves in the scientific process. From our results, we realized that students gained a significant understanding of how science works. First, they were able to understand that science is not all about experiments, but most importantly, about data collection through observation and making of inferences. Secondly, they were also able to understand that science changes over time whenever new evidences occur. And this does not make science flawed, but rather it makes it a robust process and makes it more self-correcting. Lastly, they were able to understand that science is actually a human endeavor, which is actually built through collaboration and debate within the scientific community. In a society where trust in science has become much more important than ever, teaching how science works has become important just as teaching what it discovers. Through this intervention, students are able to understand and to be able to know the importance of data and the scientific process in generating our scientific knowledge, to be able to not make unconfounded, non-evidential statements like climate change is not real. Thank you.
Great job. Thanks so much, Martin. Next, we'll have Somoy Das, and she'll come to talk about increasing investment in Indianapolis public bus transit for a sustainable future.
Hi. So before I start my pitch, I would like to ask you how many of you take public buses to travel somewhere? Yeah, thank you. So originally I'm from Bangladesh. When I moved here from Bangladesh, I didn't have car and I don't have it still now. So I thought, no problem, I'll just take bus to travel to my school. But quickly I learned to avoid it. Why? Because I was scared. And it's not only me, but also my American and non-American friends, my colleagues, even my neighbors share the same thought. They are scared because of the shady bus stations, old infrastructures, the fear of getting robbed, and also the long wait times. So the cost of this social problem is even huge economically and environmentally. Research shows every $1 billion invested in the public transit system, it creates up to 50,000 job opportunities. And environmentally, we cut back 55% carbon emission every time we choose public transit over using car or Uber alone. So how do we fix this problem? One of the solution is policy implementation. And in my policy analysis research, I analyzed 3 policy alternatives. One, maintaining the status quo without investing a single penny in the current system, but that's not certainly working. And the second, public-private partnership, creating the opportunities for billions of dollars investment. But that is also lengthy process and may never take place anytime sooner. And the third alternative, which is most effective and politically feasible, is step-by-step investment in our current system, utilizing our existing 22 million fund from our Indiana's public mass transportation fund. So the money is already there. We can utilize this state fund combining with our federal grant fund and start from where it matters most. So starting from safety issues, put security cameras and metal detectors at our major bus stops. Second, run robust public awareness campaign to break the stigma around public transit system. And third, demonstrate this gradual progress to our private and public leaders to secure future investment. So sometimes the best option is not choosing the biggest biggest solution, but it's the one that we can start from right now. Thank you.
Great job. All right, next we'll hear from Lukman, and Lukman is going to talk about head rat rodent model of alcohol use disorder.
I want you guys to close your eyes for a moment. Imagine with me, you're walking down the street and you see a little red button on the sidewalk. You kneel down, press the button, and you get shocked. Kind of retreat your hand really quickly and you keep walking down. You see a booth with a little blue door. Kind of curious, so you open the door and you get punched in the face, square in the face, rubbing your eye. You finally manage to get to your car, you get home, and you have a bowl of soup. It tastes good too, it's a really good soup. But all of a sudden it's really bitter. All three of these actions, you can open your eyes again, led to consequences, adverse consequences. In addiction, despite these adverse consequences, people keep coming back to the action. Alcohol use disorder is the same situation. People keep coming back to the alcohol. Now, there's a special rat that Dr. Hardy mentioned called the had rat. It's a had rat because it's high alcohol drinking. Why is it high alcohol drinking? Because it has been selectively bred to do that. Now, this rat is very helpful to us because it's a great model for high alcohol use disorder. What we want to do with the rat is understand its motivation for drinking. Why does it drink so much? Is it trying to relieve a negative emotional state, perhaps? Is it trying to reach reward? We want to know why. So we're tackling the negative emotional state through anxiety, which is a famous negative emotional state. How we're doing that is, the way rats work is, if they are far away, they are displaying a high amount of anxiety-like behavior. If they're close and they're sniffing at each other, all happy, that is low anxiety-like behavior. So we want to observe this behavior to understand that negative emotional state that may be in the had rat, and potentially understand individuals with a genetic predisposition to alcohol use disorder, and maybe even help more people to come out of the situation that I described with all those negative, adverse consequences. Thank you so much.
Okay, so it's going to take a short pause for the cause and share with you a resource from the Graduate School, our Grad Parent Network. This is for graduate students who are parents. This network provides support and a networking platform for graduate students who are parents, and it meets monthly on Zoom from 12 to 1 p.m. You can find more details on our website. Judges, how y'all doing? You need a minute?
I think we're good.
All right. Next we'll hear from Devashan, and she's going to talk about red teaming of AI addiction for addiction recovery.
So nowadays, do you think we have any escaping from AI? I don't think so. Even the slide that you see is made by AI, partially, of course. So this traffic signal pretty much sums up my research. So let's start with the red signal. So herein, we analyzed Reddit posts and conducted digital ethnography of 300 plus Reddit posts. And they were the people who used ChatGPT for addiction recovery. And we found hope and harm both through the data. Some people said that AI is a helpful companion which helped us recover, while some say it's too risky of a system to be used for such sensitive areas. With this thing, we move on to the yellow signal. That is, we took this data and then we conducted stress testing. Participants were recruited who had no history of addiction, and they were asked to stress test the system with using a red teaming protocol, wherein they would ask AI emotionally heavy and difficult questions like, what if I relapse tonight? Can I have one more drink? I'm feeling worthless. These systems exposed the misaligned judgment, the hallucinated advice. This was taken forward to the third phase, which is the final go, wherein the data collected from digital ethnography and stress testing was finally analyzed for failure patterns. and then failure patterns, and then it was used to form practical guidelines. With this, a system much better could be developed, which had better guardrails and healthy boundaries. Because if somebody uses AI at 3 a.m., when the person is struggling and vulnerable, AI should get it right. Addiction recovery is already hard, and AI should in no way should make it harder. Thank you.
All right, next we'll hear from Mrs. Sweeney, and she'll be talking about hunger meets healthcare, the social risk behind readmission.
Imagine a revolving door in a hospital. Patients come in, they get treated, most of them come right back. We often attribute these readmissions to a medical problem, be it hospital be it medication adherence or treatment quality, etc. But what if these readmissions aren't random? What if they reflect social risk? That is exactly what the project is on. The driving question for this is that how do demographics, program participation, and social risks like food and financial strain affect hospital readmissions? And what I mean is that we'll be focusing on who the patient is, what support they can have access to, whether their needs are met, to analyze hospital readmissions. It is food insecurity by definition means that not having consistent access to resources and nutritious food to live a healthy life. It matters because in the United States alone, 1 out of every 8 households is food insecure, and financial strain is one of the top contributors for poor health. Coming to the first part, which is who the patient is, through our analysis, we were able to show that patients who are predominantly women within the age groups of 50 to 65 who are multiracial and come from a Latino or Hispanic ethnicity showed the highest readmission risks. Coming to the second part, what kind of programs they have access to. We were able to see that compared to educational programs, that is diabetes, hypertension, WIC, we were able to see that the veggie box programs and the Sky Farm showed that they lowered readmission risk. Sky Farm is literally a farm on top of the hospital. Fascinating, I know. And then coming to the third part, which is the social risks, which is food and financial risk, it showed that patients who screened positive for food and financial strain, 78% of them were readmitted, 22% of them stayed out of the hospital. What can we conclude? What kind of impact can we create with these findings? We can show that hospital readmissions are not just clinical failure; they can also be a social signal. We can use these findings to provide the support and care to the populations that are vulnerable and strive towards the future where fewer of these populations go to bed hungry and get the accessible care they deserve. Thank you.
Great job. Thank you so much. Awesome. So now is your opportunity to choose your favorite 3MP presentation. So take your ballot out and put a check mark by the one person, not multiple check marks, that you have deemed and declared is your favorite People's Choice person. Great, great job, everybody. Thank you so much to all of our 3-minute pinch competitors. Great job. All right, while you are voting, let's connect, okay? We just had a great session on LinkedIn, so you can follow us on LinkedIn, Instagram, and we have an awesome YouTube page that's a great reference as well. So these are all of the IU grad school and grad school associated pages. Follow us. It's great information. and a great way to stay connected, build your networks, and build community. All right, so we're gonna shift gears and go into our 3-minute thesis competition. With our 3-minute thesis competition, all of these students are PhD students, and they are currently working on these wonderful projects. Okay, so we're gonna get started with Stephanie, and Stephanie's gonna talk about light in the dark, uncovering how genetic ancestry shapes breast cancer outcomes in Black women.
What if you were told that a small change in your DNA passed down from your ancestors can affect how your body fights cancer? You'd be curious to know, right? Over many generations, our bodies have adapted to different environmental climates and conditions to survive. For women from sub-Saharan Africa, one of these changes is in a gene called DAC. Now, this once offered protection to their ancestors from malaria by preventing malaria parasites from being able to enter their red blood cells to cause infection. But here's the twist to this. This same defense that once saved lives from malaria may affect how your body fights cancer. And as migration happened, this spread across continents. And today, about 40 to 60% of African American women carry this change in the DAC gene. So what happens when there's a change in the DAC gene? It alters how the cells in your body communicate, creating signals which these cancer cells then use to grow and spread. And why is this all important? Statistics from the American Cancer Society has shown that even though white women have a higher incidence of developing breast cancer, Black women are 40% more likely to die from it. So could this be one of the reasons why Black women are often faced with aggressive and worse outcomes of breast cancer? These are the questions at the heart of my research. So think of DAC as a traffic signal, working well to prevent cancer cells from spreading in your body. But when this traffic signal malfunctions, it creates mixed signals, which these cancer cells then hijack to use to grow, survive, and spread within your body. So in the lab, we analyze these signals to find where the communication breaks down and how we can restore balance to it. By so doing, we can develop drug targets that can act as skilled engineers to repair the system and stop the cancer cells in their tracks. It is my hope that by shining more light into this DAC gene, we can illuminate a future in cancer care where every Black woman seeking treatment is confident that the therapies available are well suited for improving care and are also truly informed by their ancestry, their genetics, and their story.
Great job. We got some amazing presenters. I'm not mad at the judges right now. Next we'll have Oluwadamisi, who is going to present to us on the experiences of international students in the U.S.
Picture everyone and everything that matters to you today. Imagine packing some of your items and picking them and putting them into 2 checked bags and a carry-on luggage. How would that feel? It'll make you feel daunting. This is the reality of every international student across the United States. According to the Institute of International Education, the United States hosted the largest share of international students globally, which were 1.1 million people who migrated to the US in pursuit of education. Through interviews, I used Kim's integrative theory of cross-cultural adaptation to investigate the barriers faced by international students and how they adapted. This theory explains the complexities of the adaptation process and its role in intercultural exposure. The study revealed that international students experience communication barriers due to differences in accents, and to cope, they asked people to repeat themselves often, using words like pardon and excuse me. And this helped them to adjust. Additionally, they experience translation gaps because not every word can be translated into the English language with the same weightiness of emotions. However, they expressed that they were homesick in the first week and they missed family, food, and community. But they learned to adapt by intentionally seeking out community. They learned to ask for help, with one student stating that, learn to ask for help and people will take your hand and take you places. They expressed that they grew professionally through self-exposure and expanded network. International students bring along with them an opportunity to introduce skills like cultural competence and cultural humility, skills necessary in the global workplace. So, look around you. Look at every international student. These are not just another immigrant trying to study abroad. They are people who are resilient, people who bring with them an opportunity to contribute to their host community. These are the voices of international students across the United States. And these voices represent me too because I'm an international student.
Great job, thank you. All right, next we'll have Gunjan Akbari. She'll talk to us about detection of dark matter.
Good morning, everyone. My name is Gunjan Akbari, and today I am going to present my research. This is the detection of dark matter. So, everything we see, like stars, planets, you and me, everything makes up less than 5% of this universe, and the rest is invisible. So, that invisible part of that universe, we call it dark matter. A cosmic ghost that holds galaxies together yet refuses to be seen. So I find it to make a way to make invisible to visible. How? So in my research, I use a small piece of americium-241, which is the radioactive material. So I place it in a strong magnetic field.
You got this. Yes.
No.
We still have time. That was good. That's it takes so much bravery to stand up here, period. And then to see a host full of people, you did a great job. Thank you so much. And great work, and continue on your research. We are here to support, okay? Nobody in this room is here to tear anyone down. Right. We are uplifting. We, though it's called a competition, it's not even that deep, okay? All right. So I want to remind you guys that Elite 50 happens every year, and you guys are amazing. You are elite. So you can nominate yourself for this award. We encourage you to do that, okay? The short link that's down at the bottom below, that is where you will go to nominate yourself, and if you're not nominated, you cannot apply. So go ahead, do this self-nomination, apply for this award, get this award, put it on your LinkedIn, right? So, and showcase your skills and your talents, and definitely take advantage of that. And if you've already won Elite 50, nominate some friends, okay? Absolutely. I also want to acknowledge our dean is in the house, in the space. Our dean, Rebecca Ellis. It's over here in the space. Coming to learn more about all the amazing work that you guys are doing. And you're doing great work, and we're so proud of you. So next we'll hear from Alexa, and Alexa will speak on old drugs, new tricks, drug repurposing in Alzheimer's disease.
Medications are expensive. They're expensive to take because they are incredibly expensive to make. From the lab to human trials, it costs an average of $2.6 billion to put one new drug on the market. Show of hands, who pays taxes? That should be everybody. I'm not the IRS, I swear. So I'm getting everyone to show that our tax dollars actually pay for drug discovery research. So give us all just a quick round of applause because we're all drug discovery contributors. Yes, that is so much work being put into one drug. And there are actually over 20,000 FDA-approved drugs on the market. So what are the chances that one of these drugs can actually treat a disease like Alzheimer's? A disease with no cure that affects 55 million people worldwide. This is where drug repurposing comes in. So in order to understand this, think of your body as a corporate office. You know, the one that you have to work so you can pay for your medications. So your genes are managers. They give out instructions on how to maintain your body in you. But in Alzheimer's, this office is in chaos. Maybe you have a manager that stops showing up to the memory department and suddenly you can't remember things anymore. Or maybe it's hard for you to do something simple like remembering how, when, and why to clap like you guys did earlier. Or maybe you have a manager that is overworking and burning out entire departments and now you're at increased risk of stroke. Drug repurposing finds the right existing drug that brings your office back in order. So how do we do this? We take genetic data from people with Alzheimer's and we see which genes in these Alzheimer's patients are overworking or underworking. And then we take genetic data, then we oh my gosh, sorry, I said them one at a time and I got startled. Okay, so then we take a look at an existing database of existing drugs and we see which drugs turn off those overactive genes and turn on those underactive genes. And that makes it's a beautiful thing because we already know how these drugs work. I mean, we made them, right? And thus far, we found several cancer therapies that appear to reverse those Alzheimer's disease, signatures. And so what is it that I do for research, you might ask? Well, it's simple. I make medications work for you, not you work tirelessly to afford your medications. And so I want you to think about as you continue your clapping, that how easy it is to do something like that, to remember why and how we clap, and that it shouldn't be expensive to maintain that. Thank you so much.
Great job. So many great presentations. This is pretty awesome. I love it. All right, Afrin's going to come to us next and talk about how a new prescription drug changes the story in breast tumors.
So last year, I was volunteering for the IU Cancer Center at the Indiana State Fair. And a woman, she stopped by our booth, and with a big smile, she said, "I'm a breast cancer survivor, and I got my treatment at your cancer center." That was, of course, a proud moment for me, but at the same time, I could relate when she said she still have several side effects coming from that treatment. And as a breast cancer researcher, I know that she is not the only one. Breast cancer is the most commonly diagnosed cancer in the United States female that make 1 in every 8 women to be diagnosed with this cancer during their lifetime. And that could be our mother, our sister, or even ourselves. So what treatment options we have for this huge number of patients? The current treatment are really not enough because they have major side effects. And that's why my research questions if we can come with a better and safer drug with no major side effects. To understand my research better, we have to know that inside a tumor, we just not have the cancer cells, but also lots of immune cells. And these immune cells are supposed to protect ourselves. But cancer is a very smart disease, and it knows how to hijack these immune cells. And that's why we can see a lot of cancer-promoting immune cells and very few cancer-fighting immune cells. And I question if we can flip this number. And to answer that question, we developed a therapy that we have tested in our breast cancer mouse model, and the results we got are surprising. We found that the treatment decreased the tumor growth in the treated mouse. Not only that, it also increased the tumor fighting immune cells and decreased the tumor promoting immune cells. So our treatment is just not targeting the cancer cells, it also helps the body to learn how to fight back. And in future, we are hoping to test this drug in real patients in breast cancer clinical trial to make their life a little brighter and a lot easier by turning the cancer's allies into enemies. Thank you.
Great job. Learning so much. All right. Cian Elliott is next, and Cian's going to talk to us about impact of DIS3 mutations in multiple myeloma.
So you might not have known, but Queen Elizabeth II had multiple myeloma when she passed away. Towards the end of her life, she suffered from tiredness and weight loss, both common symptoms of multiple myeloma. Multiple myeloma is a blood cancer that affects plasma cells in the bone marrow. These plasma cells overgrow and cause your bones to become brittle. In the United States, nearly 168,000 people are affected by this cancer, which makes up about 2% of all cancers in the US. This is also typically a cancer found in the elderly and has a median age at diagnosis of 69. It's the second most common blood cancer, and it has a 5-year relative survival rate of 62%. One of the most commonly mutated genes in multiple myeloma is a gene called DIS3. This gene plays an important role in the cellular complex known as the RNA exosome. You can think of the RNA exosome as a trash can for RNA in your cell. This is important because in your cell, DNA gets transcribed to RNA, and then RNA gets translated to protein. When there's too much RNA, good or bad, but especially bad, the RNA exosome degrades it, and DIS3 is the one actually doing the degrading. In multiple myeloma, there are 2 DIS3 mutation groups, hotspot mutations and non-hotspot mutations. Now, for every gene in your body, you have 2 copies, one from your dad and one from your mom. In hotspot mutations, there's 1 mutated copy, and we know that these mutations function in the RNA degradation activity of DIS3. In non-hotspot mutations, you have 2 mutated copies, and the functions of these mutations are unknown. So the goal for my thesis is to determine the differential impact between these 2 mutation groups on multiple myeloma disease progression and cellular functions, ultimately to find drug targets. So to do this, I chose 4 non-hotspot mutations and 3 hotspot mutations. You can see them on the DIS3 protein structure up here. The non-hotspot mutations are in blue and the hotspot mutations are in red. The non-hotspot mutations span the protein, and the hotspot mutations are in one centralized region, and this region is known as the active site of the protein. This is where the RNA degradation actually occurs. So we'll take these mutated cell lines that I made, and we'll do DNA, RNA, and protein sequencing to determine what these mutations do and how they affect multiple myeloma disease progression, and ultimately find drug targets that will help create better treatments for multiple myeloma patients with DIS3 mutations. Thank you.
Awesome. Thanks so much. All right. I'll take another pause for the cause, a little break, station break. Our Graduate Mentoring Center. How many of you have heard of, participated in, or done something with our Grad Mentoring Center? Yes. Okay, for the other half of you, we invite you to engage with our Graduate Mentoring Center. The Mentoring Center provides resources and opportunities that for not only faculty and staff, but for you all as well. Our Grad Mentoring Center GA is also in the space. That's Precious. Hey, Precious. So, our Grad Mentoring Center works with faculty and staff so that they are better mentors and not tour mentors. Okay, I know. You can definitely suggest that training to your mentors, to your advisors. Okay, like Dr. Hardy said, do it. It also helps with graduate professional students and teaching you all about mentoring, and we'll do a session for graduate students, a day-long, well, it'll be over 2 days, training in January for graduate students. But we also have our monthly mentoring dialogues for graduate students, and we talk about a number of different topics, from things like networking to aligning expectations to setting goals. So be on the lookout for that, and you can find more information on their website, which is on the grad school website, and in our monthly newsletter. How many of you get that GradJag newsletter every month? How many of you actually open it? Okay, that's good. We're doing great. We're doing great. All right, good job. Okay. All right. Next, we're going to hear from Lainey, and Lainey's going to talk about fighting fibrosis, targeting the cells that cause chronic kidney disease.
How often do you think about what your kidneys do for you every day? They're constantly filtering your blood 24/7, helping to maintain your blood pressure, balance minerals, and remove waste in your body. Now, imagine if your kidneys stopped working properly and their function continued to decline. That's what happens in chronic kidney disease, or CKD. CKD affects 1 in 7 adults in the United States, which is about 37 million people. Sadly, about 90% of people with CKD are not even aware that they have the disease. As CKD progresses, it can lead to end-stage renal disease, where patients' only treatment options are either dialysis or a kidney transplant. CKD is more than just a problem with filtering waste. It's a disease of scarring. Over time, scarred tissue builds up in the kidney, overtaking the healthy kidney tissue. My research focuses on the scarring or fibrosis aspect of CKD. I'm interested in looking at changes in fibroblasts that become overactive in CKD. I've found that these fibroblasts share a common trait. They overexpress a protein called fibroblast activation protein, or FAP for short. This led me to wonder, is FAP simply just a marker of disease, or is it actually something that's driving CKD? To test this, I used a genetic mouse model that has deletion of the FAP gene. In these mice, I found that they had decrease in fibrosis genes as well as improved kidney function. This was a really exciting discovery that showed that FAP may actually be playing an important role in the progression of CKD. Next, I plan to take this discovery one step further by testing new drugs, both nanoparticles and small molecules that target FAP in my mouse model of CKD. By killing the cells that express FAP, I expect that these mice will see less fibrosis and better kidney function. This is a really exciting stage for my research because it helps move my work from the bench to the real world to hopefully identify drugs that could treat patients in the future. By tackling fibrosis at its root, my hope is that one day we can slow or even stop the progression of fibrosis when it reaches the point of no return. For the millions of patients living with CKD worldwide, this can mean more independence, not having to go on dialysis, and living a longer, healthier life. Thank you.
Awesome. Thank you so much. Everybody's done such a great job. All right, Meredith is up next, and Meredith's going to talk about what happens in the kidneys doesn't stay in the kidneys.
When most of us think of the kidneys, most of us think of it as the body's natural filtration apparatus, quietly cleaning your blood hour after hour, day after day. Well, what if I told you that your kidneys also protect your brain? Chronic kidney disease, also known as CKD, the stat I have is over 35 million people, so we're meeting in the middle, is affected every year with this disease. And that's because CKD often progresses quietly, to the point that when symptoms including confusion, swelling, inflammation, by the time those things show up, it is often way too late, with systemic dysregulation happening, and it leads to these comorbidities including heart disease, inflammation, and dementia. So what that tells us is that this disease that we've long treated as a disease of isolation, a disease of the kidneys, where we're having all this waste build up, instead we're really beginning to treat it as a disease of the system, where when the kidneys falter, the whole entire body falters. And that's what my research focuses on, is this connection between the kidneys and other organs, specifically the brain. And we study this by looking at a protein known as Tamm-Horsfall protein, or THP. THP is made only in the kidneys, and most of it escapes into the urine, where it protects your ureters from urinary tract infections, or UTIs. But some of it escapes into the bloodstream, where it does something pretty cool, if you ask me. It protects your cells when it's stressed out, and it tells it to just take a chill pill. And with that, in CKD and aging, what we see is your kidneys lose the ability to produce THP. So when we look at this in mice, we see not only signs of chronic inflammation, but we also see reduced movement, especially in female mice. And so what this might tell us is that THP is acting on those vulnerable cells that you have that control your movement. And so we decided, okay, maybe this is also possible in humans too, and it is. Because when humans have higher levels of THP, they perform better on their movement and coordination exams. So we think all of this is taking place through a stress channel that's known as TRPM2. So you can think of TRPM2 as a bridge that clearly had its main part fall in. So I don't know how well calcium will make it to the cell on this bridge, but you can think of TRPM2 as a bridge where calcium crosses over TRPM2 and THP decides whether or not it gets to come into the cell. And when THP is there, everything's normal, your cells get calcium, but when THP is not there, calcium flows in unrestrained. So in studying THP, we're learning that what happens in the kidney doesn't always stay in the kidney, and it might protect your brain too.
Great job. Y'all see this troll she made?
There was a bridge there, I swear to God.
Katrina is out sick today, so we're sending her warm thoughts. She's got the flu. She emailed me this morning. So our grad common space, have you guys been using the grad common space? Do you know where it is? Really? Okay, so we have a space that is open to everyone. Anytime the library is open, the grad common space can be utilized. It's on the 4th floor of the library. So when you come off the library elevators, you turn to your left, there is a glass wall or room enclosed there. And with your ID card, you can get into that space. It is a quiet space, a studying space, where you can do all of those things, right? And so starting December 4th, that's when Stress Busters Week start. We'll have some snacks up there. We'll throw our Keurig up there as well, so you'll be able to access that. So please do utilize that space. All right. Next we have Nita Shari. I said that really bad too.
You tried.
I did make a valiant effort, but I don't know if it was that valiant. Say it for me.
It's Nityashri Maheshwaran.
Yes.
Don't worry, people don't get it because I'm so fun. You can call me Nima, so I go by that.
Awesome. All right. So Nityashri, yes. It's going to come and talk to us about balance between life and death, targeted redox vulnerabilities, and aggressive cancers.
So many of you in this room may know someone who has faced cancer, a family member, a friend, or an acquaintance. I lost someone close to my heart to cancer.
Every year, cancer touches nearly 1.9 billion people in the United States and thousands here in Indiana. Among them, some face the most aggressive cancer that resist treatment and take away lives far too soon. Pancreatic cancer, for example, has a 5-year survival rate of only about 12% and is the third leading cause of cancer death in the country. This is also the cancer that took away the life of Steve Jobs and is the one I studied. In the heart of these tumors lies a fragile chemical balance inside every cell. This is a quiet conversation between molecules that decides whether a cell gets to live or die. Scientists call this redox signaling. In healthy cells, this balance keeps life running smoothly. But in cancer, tumor cells hijack this system to survive, grow, and resist therapy. One key player in this process is a protein called REF1 or REF1. So this is kind of like a master switch that cancer cells use to repair themselves and adapt under stress. Over the years, our lab has developed inhibitors for REF1, and some of them have been tested in clinical trials for solid tumors. But as powerful as this drug can be, cancer rarely surrenders to a single weapon. And that's where my work begins. As a pharmacology researcher, I'm designing combination therapies. Think of them like drug cocktails, the good kind. I combine our REF1 inhibitors with metabolic pathway blockers to starve tumor cells from within. Using advanced 3D tumor models and preclinical mouse systems, I study how these combinations influence tumor growth and survival. In simple terms, we don't just cut the power, but we also starve the cancer cells. By identifying the most effective cocktail, we aim to move this therapy towards clinical trials and ultimately give patients facing pancreatic cancer a better chance at survival. Because cancer is more than just a disease. It's a challenge that affects many lives. Through research, we have the chance to restore the balance between life and death and bring a future where diagnosis no longer means defeat, but the beginning of a cure. Thank you.
Great job. Next we have Emmanuel Odi, who will come and talk about the perfect soldier, many wonders of a fly's genome.
I look human because my genome tells my body to make me this way. I have 2 hands, 2 legs, no tail, no wings, yet tiny genetic differences explain why I don't look like you and why no 2 individuals here look alike. Now, genes encode our body's abilities and traits. And to understand how these genes translate into these physiological traits, I study one of the nature's most toughest organisms, the black soldier fly. Now, the question is, why study a fly? Now, the black soldier fly thrives where most organisms fail. It is tough, adaptable, and resilient. And all of this trait comes from its genome and physiology, giving it an extreme metabolic flexibility, an extraordinary immune defense system, rapid growth rate, and also resilience to toxins and pathogens. But beyond the science, the black soldier fly is a driver of a $500 billion industry across Europe, North America, and Africa, formed for its application in food for livestock, organic fertilizers, as well as some pharmaceuticals and industrial derivatives like antimicrobial peptides, biofuels, cosmetics. Now, my PhD research asks one question: how does its genome mix these superpowers? And in order to answer this question, I study the genome and look at specific genes of interest. Now, imagine reading a recipe to making your favorite dish. In this case, the favorite dish would be growth or immunity or other traits of interest. And I also need to mention that even though the fly and the human looks completely unalike, they share conserved genes and pathway for growth, development, and others. So genetics has come a full cycle. Genetics When modern genetics started 100 years ago with a fly, the fruit fly called Drosophila melanogaster, and today, 100 years later, another fly, the black soldier fly, which I call the perfect soldier, is helping us advance science and biology. And also driving the global industry, reminding us that some of the most powerful insights in biology comes from tiny little wings. Thank you.
Thank you, and he did all that with his hat under his table. Next we'll hear from Emmanuel Osi, who will talk about how physics helps us understand. I said it really bad. I'm sorry. Okay. How physics helps us understand Parkinson's disease, one molecule at a time.
When you wake up and feel that spark of energy, you know it's a tiny messenger responsible for that. That's called dopamine. This molecule is often called the molecule of motivation and responsible for movement, smiling, and the excitement we all feel in this room. But in Parkinson's disease, this tiny messenger begins to fade, such that using your hands to lift a cup becomes a problem. Doctors try to restore this with L-dopa, a molecule the body converts into dopamine in the brain cells. Yet, decades of using this molecule and trying to understand how dopamine causes Parkinson's disease, we still don't fully understand how they behave once they enter the brain cells. That mystery is where I come in, not as a biologist, but as a physicist. I study how L-dopa and dopamine interact with lipid membranes. Through several simulations and experiments, I've uncovered how dopamine and this molecule attach, bind, and influence lipid membranes. That is the protective barrier of the brain cells and the first layer of every cell. The results show a rhythm, a molecular dance that shape how the brain communicates. Piece by piece, I'm unraveling several physical forces and parameters that describe this Parkinson's disease and the chemistry of life. These results are very critical because it will help us design better drugs for Parkinson's disease, help restoring the movement they lost and the joy dopamine gives. So the next time, when you are cheering up a game or you feel motivated, always remember there is a physicist working behind the scenes to make sure these motions are kept alive. Thank you.
Okay, physicists, I see you. There are a wealth of grad school resources on our graduate school website. I encourage you, if you have not already bookmarked this page, please bookmark the page. It's our one-stop shop for all of these different things, including funding and fellowships and guiding you through your dissertation. Okay. Next, we'll hear from E-Ray, and he'll talk about Take My Breath Away, harnessing Excel biomarkers for disease detection.
Hello everyone. I'd like to start with a quick activity. So if everyone could breathe in, and now breathe out. We've done a lot of that today, I know. So what do? We inhaled and we exhaled, right? That's not all that we actually did though. Everyone that exhaled in that demo and earlier this morning actually released hundreds of what are known as volatile organic compounds, or VOCs, which I'll call them that for the rest of this talk. These are these blue little molecules that you see on the screen. So what are they? They're kind of like the trash of the body. They're introduced into us through what we eat, what we drink, what we're exposed to, the clothes we wear, the air we breathe. But the phrase, one person's trash is another person's treasure, could not be truer, especially for me, because these VOCs have demonstrated tremendous promise as non-invasive biomarkers for disease detection. If that wasn't cool enough, the huge inspiration of this research field comes from canines. This is Sadie, or Miss Muffins, as I like to call her. Canines can be trained to smell people's breath And these dogs are able to recognize a change in that person's breath due to a disease they have like diabetes. So as researchers, we have been inspired with this question of which VOCs in particular are these dogs actually smelling that triggers Sadie to stick her paw out and say, hey, you need to check your blood sugar right now before you collapse. Because if we can identify those molecules, we can get to a point where we could build a breathalyzer that would be in the hospital. Imagine one day you walk into a clinic and instead of getting a rectal exam, a blood test, or a mammogram, you could breathe into a sensor and it would tell you if you were sick or not, or if you had cancer or not. As exciting as that is, one of the biggest problems within our field of research is that we as breath researchers cannot seem to agree on a universal breath sampling method. Everyone does it a little differently, so it makes translating the studies really difficult. And furthermore, if you use a really experimental breath sampling method, your results may not be all that reliable. And if we don't have reliable VOC biomarkers, we have bad diagnostic tools and we can't get to that breathalyzer. So this is where my thesis work tries to push the envelope with this problem just a little bit, where I say, hey, if we still don't know what we're doing with breath sampling methods, we should take the time to develop not one, but two really good ones and use them in parallel when it comes to actually sampling breath. So I spent half of my PhD building two breath methods, and I sampled breath samples from over 150 people on this university's campus and independently analyzed the data. I want you to think of using two methods as fact-checking. Method one is verifying method two, and vice versa. And at the end of the day, I found 12 unique VOCs that were present in both of these methods. So the takeaway message here is, hey, until we can agree on one, keep using two so that we can build that breathalyzer. Thank you.
So interesting. They got your collective breath. I love it. Next, we'll hear from Gary. Gary's going to talk to us about combating climate change and addressing food security through insect-based protein sources.
Hello, everyone. Are you hungry?
Yes.
Did you eat the food like me to eat? Ready for lunch? Right? How privileged are we? Every 4 to 15 seconds, starvation claims a life. 1 in 10 children dies of malnutrition. About 36% this year in this country, we had food insecurity. 1 in 5 children go hungry. Can you believe that? So where does all the food go? So much of food is being produced, right? Where does it go? You see here, the cow and the dog? Yes, it goes there. It takes about 7 kilograms of grain to produce 1 kilogram of beef. Not to mention the water and fertilizer. And also, 9.2 million tons of plant and animal protein goes for pet food industry. Do you all love pets like me? Of course we all do, right? They're so cute. To top it off, 40% of the food in the United States go as waste. What is the solution for this? My research has a solution, which is very infancy. And nobody likes it. It's like, you bugs! No! So we need to reimagine the food system with the help of the insect world, which is highly not touched. That's their ecosystem, right? Poultries and feeds livestock, they used to feed on these insect world, right? So my research is focused on using black soldier flies, which has the capacity of transforming the waste into highly nutritious protein, and that protein could be used for feeding our lovely pets and the cows to make good beef. That protein, animal protein and the plant protein, 9.2 million tons or so, can be used for human consumption to tackle the food insecurity and the food problem Are you ready to reimagine the food system?
Yes.
Ready to build a resilient food system?
Yes.
Take an oath. Thanksgiving is coming. Let's not waste food. Thank you.
The charge has been given. Eat that turkey.
Let's not waste food.
All right. The Young is coming up next, and she'll talk to us about the hidden water we overlook, discovering the power of dew.
Hello? Oh, yes. Have you ever heard this word before? Dew? Yes. Have you ever noticed it in our daily lives? Well, sort of. Dew is a very common phenomenon in our daily lives. It condenses from the air on the surface of the objects, for example, on the grass, on your mailbox, or on the car's window sill. But the problem is, why do we always overlook its power? Probably because it's very tiny, right? Well, unlike rainfall, a heavy dew won't mess up your daily routine or flood the street. At most, it's just a weight your shoes when you walk through the grass. But after studying dew for 2 years also, I've noticed its power. So today, I'd like to introduce 2 ways how dew shapes our world. First, in arid regions where water is limited, dew is a very important alternative water source. People in such regions have long recognized its power. It forms regularly and reliably. So they have explored many ways to collect it. For example, you can see from this picture, in France and India, many dew condensers have been built for harvesting dew from the air, for providing drinkable water and fresh water for people in such regions. It can provide 5% to 15% drinkable water. Besides benefiting humans, dew also influences plants. Well, now imagine you are plants growing in a desert. You are always thirsty because of the limited water in this area. But every morning, a thin layer of water forms on your leaves, and that's dew. It provides you with a small but steady water source. So in this way, you can maintain your regular physiological activities such as photosynthesis, water uptake, and surface cooling. Well, with the help of dew, millions of plants can survive in such harsh environments. Well, finally, I want to leave you with one last thought, and that is, even small changes can make a difference. Even dew is very tiny, it matters. So it can provide water for both humans and plants. It sustains life and it offers hope for the future. Well, as a researcher, I hope that one day the effects of dew will be better understood because it won't just be a natural phenomenon, but a global solution of water scarcity. Thank you.
Wow, great job, everyone. Thank you so much. So now is your chance to vote for the People's Choice Award. Yes, again, we are voting on comprehension, content, engagement, and some of y'all probably vote for your best friends. It's all good. Take out your ballots and place your votes. Yeah. Want to thank my fantastic grad assistants. Sham had to leave because he had to go to class. Precious, where you at? There she is. Meg had to leave also, but Meg was here at the front table earlier today. They are certainly amazing and fantastic and just wonderful graduate assistants. So yes, thank you y'all especially. I want to give a shout out to my graduate emissaries. I know I got a few in the room that have been with me all day that have just taking whatever Dr. Hardy asked them to do. They just were like, okay, thank you. I got it, Dr. Hardy. Thank you. I appreciate it. And I really appreciate your work, and thank you for being a part of that program. It's such an amazing thing and an amazing program. Everybody knows this evaluation, or at least working on it? Okay, great. All right. So we're going to start with a few door prizes, and then we're going to talk about our 3-minute pitch winner, runner-up, and then we're going to go to our 3-minute thesis winner, runner-up, and our People's Choice Awards. All right, so I'm going to start out with a door prize from Up and Go. I know. You can win this lovely Up and Go t-shirt. Does not glow in the dark, but you will will stand out in any crowd in this shirt from Up and Go. All right. All right. So I'm gonna just use our sign-in sheet. So hopefully you guys sign in, and I am going to randomly pick a name who hopefully is still here. Celia? Is Celia still here? Celia's right here. Yes, Celia talks for us. Celia. What size shirt you need, Celia? Yes.
Large or extra large?
I got an XL in my hand, I think.
I'm coming.
Come on now. Yes. Love it. Large? That's a large. Extra large. Yes. All right. Great. Awesome. Yes, thank you. We're excited. All right. I got lots of shirts. All right. Our next giveaway is another highly coveted t-shirt. This one is from our Graduate Mentoring Center, who empowers successful mentoring relationships. You two could be a winner. All right. I'm going to go to the one that everybody has to sign in, so I might not be able to read the. Oh, ha! Kristen Chin! All right.
I'll take the horizontal.
All right. Okay. Add that to your. I know. Amazing. All right. I have another gift combo from the Graduate Mentoring Center. Not only will this person win a t-shirt like Kristen did, but they will also win Junior Jaguar. Junior Jaguar, our newest plushie of the plushie families, with his Graduate Mentoring t-shirt on. Gotta love that. Super cute. Hey, long. With a GMC shirt. Right. Have Kristen come pick a name. You already won. Let's be present to win.
Clarissa Trent.
Whoa! Love it. You have won the highly coveted Junior Jaguar. I'm so excited. Hey, tell me what size shirt you need. Medium? Oh, I think Kristen might take my medium. Or I got a large too. Okay, I get a large. We'll go back. Love it. We brought size. Awesome.
Take a couple horizontals real quick.
Love it. The joy of my day. All right, love that. Okay, we also have a few grad jag swag bags. Try to say that 5 times fast. All right. It's hard. Totally a tongue twister. It's all good. All right. So pick a few more names. Oh, Alexa, yes.
Just thinking, I have so many bags.
Really?
I was like, it'd be so ironic if I got the bag. But I love them. Thank you. Thank you so much.
It's one more.
Thank you.
All right, I'm not looking.
I have a bag with bags inside.
Mindy, is Mindy here? Mindy? Mindy here? Mindy's not here.
Can I kindly pass that opportunity for somebody else?
Oh, yes, you can. Okay. Yes. Mindy is feeling like very philanthropic today. Okay. Not looking. Oh, I think this person has gone. I don't see them in the room. Must be present to win. Okay, it was Emmanuel Odie. I think
He had class.
He had class, so he had to leave the room. Okay, no worries. It's okay. Tell him he was a winner, and he is a winner. Let him know for me. Let him know. Daniel? Is Daniel here? Oh, must be pressed to win. Oh, Daniel's not here. All right. Okay. Chloe. Well, hey, Chloe. Yes. You're so welcome. It's full of all kinds of great things. Professional too.
There we go.
Love it. Love it. All right. I don't know if I can read this name. I think it is Maine Deborah. No? Yes! All right! Yes! No, I said it very wrong. So glad that you made it though. And you're a winner. Yes. Perfect. All right. And if you didn't get a prize and you want a prize, we got prizes left over, we'll give you a prize, no problem. Okay. All right. We'll hear you on that. All right. So I'm gonna go ahead and start our awards. All right, so I'm going to start with the People's Choice Awards for our 3-minute pitch competition. Drum roll, please. I love a good drum roll. All right, Martin, you are our winner. Winner of $200. You want to open? There you go.
There we go.
Love it. Great job. All right. Our People's Choice for the 3-minute thesis is Stephanie. All right. Next, we're going to go to our 3-minute pitch runner-up. That's a roll. Love it. Our runner-up is Samoye. Get our good side. Thank you. All right. And our 3-minute pitch winner has to go to class. Yeah. Has to go to class. It is Lukman. We'll make sure. I'll make sure he stops by the grad office and gets that. And I'll take a picture with them in the office.
She wants me to get a picture of it.
Oh, okay. We're going to take a picture of it anyway. Got crop it in. We're going to do some AI and add it to the photo. I like it how AI works. Telling.
No,
It's a
no,
tool.
they won't know.
It is a tool. All right. Now we're going to go to our 3-minute thesis competition. Our runner-up is Stephanie. I'm going to rack up today. Come on.
We're talking.
Yes. Thank you. Love it.
Thanks, everyone.
Here we go.
All right, and what we've all been waiting for, our 3-minute thesis winner. Don't be trying to pick up the judges, because if it's not you, okay, don't be mad at the judges. They just did their job. All right. The judge, she's like, no, I'm okay. No, you're good. Our winner is E-Ray. I will be in touch, and all of our folks, I will be in touch. Thank you guys so much. It's been an amazing day. So excited that you guys were able to join us today. Make sure that you complete the evaluation if you have not already. Take some snacks with you before you go. And thank you guys for such a lovely day. I want my judges to come up and take pictures with our winners too, and then do a couple of winners photos also. Thanks, y'all. Have a great day, everybody.
Disappear or